so I love this webinar because I think we're going to get into the real meat of the book, right? All three of these chapters are really technically grounded in some very, very important concepts that I think are what differentiate observability and its practices from monitoring, right? And so, yeah, I think all three of these chapters demonstrate the functional requirements that you need for observability. And I kind of feel like we could have spent an hour on any one of these three topics, and it could have been just, you know, webinar on their own, but we're going to jam them all into this session. So I'm excited.
We do take requests for later webinars that are deeper dives. Thank you, George, for that context. Yeah. All right. Chapter 8 is about the core analysis loop. I love this part of Honeycomb, this aspect of Honeycomb, because science. I didn't study computer science. I studied physics in college. And the one thing that I totally love about that was the scientific method. I really came away with a concept of verifying my assumptions. And I love that I get to do that with this data. The core analysis loop is about how we do debugging in Honeycomb, or I'm sorry, with observability. Technically, it doesn't have to be Honeycomb. That's just the one we're going to show today. It's different from doing debuggings with just metrics and logs. With metrics, you can see a problem and then you can look for correlation in other metrics and hope to find some insight into the problem, the cause of the problem. With logs, I've done plenty of debugging with logs as a developer, and you have to know what to look for. If you wrote the log statements, it's okay. You can know what you're searching for. You can know what each of them means. But we're constantly debugging systems that we didn't write. Either we've joined the team since it was written, or we've joined the company, or we're taking on responsibility for a new piece of the software. So the core analysis loop takes away the part that we're expected to already know what's going on. And instead gives us a process to find out what's going on. The process is kind of generic. A little bit of system specific knowledge goes a long way. And a little bit of observability tool knowledge goes a long way, as we'll see. But the idea is to start with what do you know, what alert came in. Say people are complaining that the checkout service is slow, or we got an alert that the checkout service is slow. Step 2 is to prove it to yourself. Verify this assumption. Is checkout really slow? Can I see in a graph checkout being slow? And once you can verify that, then you can start breaking that graph down. You can look for, okay, which checkouts are slow? Is it a particular user, a particular region, a particular number of products, a particular shipment method? It could be a lot of things that are making checkout slow. We can look for patterns in other graphs. We still have that ability. And we can also narrow it down to the particular requests that are exhibiting the problem. And that gives us a lot of power. And out of that, we learn something new. We learn checkout is slow when people are shipping by UPS. And from there, we can go back to, all right, now I have a graph that shows the checkout is slow for this particular set of customers. Why? Maybe we drill into a trace. So let's do that. Let's look at it.
Well, before we jump into it, right, I think a thing that I really want to stress is I love that breakdown, Jess. What you're really talking about is debugging from first principles rather than from known conditions, right? And I think the best example of that typically is a lot of folks start debugging with a dashboard, right? And a dashboard shows you
things that have happened before.
Yeah, right, of a particular set of conditions for a thing that happened at some point in time that demonstrates whether performance is good or bad. And you kind of have to know what that thing means. You have to be able to read the tea leaves and understand is what I'm looking at a good data trend or not, right? And so really what we're talking about with the core analysis loop is, right, to Jess's point, you don't need any previous knowledge of the system, right? Just start with what do you really know, right? And in Jess's example, the checkout service was slow, right? And then this is methodology, right? To just really start at the top, right? Like just figure out what is really happening in the system, start fresh, and then dig in to figure out where the problem is.
Yeah, it's very much this idea of debugging from first principles and being able to exclude hypotheses as you go along, right? To formulate a hypothesis and then to test it, and then that gives you more information about where the problem may or may not be, and then you can formulate a new hypothesis until you've really kind of narrowed it down. So it's kind of this difference between, doing a binary search, right, to figure out where's the problem, versus throwing darts at the dartboard, hoping you just, happen to hit it.
And
Right.
the thing that I love about that, Liz, is that what we're doing is providing in observability a repeatable process, right? So that anyone can drill down quickly and figure out how, one, where could the problem be, right? And just sort of figure out systematically, where in your system is a particular issue actually occurring, right? And then figure out, like, I guess how to just methodology or use a methodology to probe and figure out like where issues really are, right? Which means that anyone with any level of familiarity with the system, like whether super senior or completely new to the team, right? Anybody can debug in an equal manner, right? Which I think is not what we typically see in most engineering teams.
Yeah, I don't want to devalue that expertise. That expertise is priceless
Absolutely.
and will help you. But how do you get that expertise? Observability helps you get it. And it should help you get it if I can go over here to Chrome. Okay, so say there's an alert, the checkout service is slow. All right, I'm going to go to the front end because that's the entry point. We're looking for slowness, so I need to verify that the checkout service is slow. Okay, well, it looks like something is slow recently in here. Let's look at the last couple hours. There we go. Is it the checkout service? I don't know. Let's break this down by name. And let's see. Are any of these checkout? I can see, okay, this one looks fine. Product ID, cart ID looks okay. Checkout definitely has these outliers in it. So let's look only at those. Let's filter it down to cart checkout. And sure enough, some stuff is different. What is different? Well, this is where you might go by previous experience and be like, okay, is it user ID? Those don't look any different. Let's add some numbers. I want to see graph over time as proof. No, none of those user IDs look particularly special. Remove that one. I can see that the checkout service, the P90, definitely got slow at this point over here. So what else could I break it down by? Okay, all right. I'm not going to try stuff because that involves existing expertise, although you can just kind of go through every field over here if you want to. The fun part is that Honeycomb automates that, as discussed in chapter 8. If I go to the bubble up tab and I highlight the ones I don't like, what is different about these requests? It tells me what is different. Okay, one is, oh, well, yes, I'm going to get an alert on it. This is an error field. App.discount code. Okay, the second most interesting field, according to the statistical analysis, is discount code. One particular discount code is strongly exhibited in the yellow box as compared to the baseline, everything else. These blue bars are all the stuff down here. This yellow bar is like, well, this is interesting. So discount code wouldn't have picked that, but let's group by that field. Hop over to results, and sure enough, all the interesting ones are in the Yoink discount code, and the other discount codes look fine. Okay, now that's information that I can take to the team. Which team is going to care about that? Well, let's drill in to a random trace. Click on one of the slow ones, and we're going to find out something else. We now know we care about the discount code, and we can add that, or we can find that over here. Discount. Yep, and verify that this is a yoink one. That was the dangerous discount code. And we can kind of see why. All right. The distributed trace is beautiful because it really teaches me about what's going on in the software system. I can see it goes from the front end, this checkout request goes from the front end to the cart service. That looked fast. It went into the checkout service to currency, back into checkout. And then we've got something slow, 1.8 seconds. That's very slow. And it looks like this get discounts thing is the culprit. All right, next question we have to ask. Now that we have a suspect, we have a hypothesis that get discounts is behaving differently in these slow checkouts with the yoink discount code. We can ask, is this normal? Is it normal for get discounts to take this long? This little graph up here of span duration says no. It shows this little bullseye thingy, shows where this get discount span lands in duration relative to other ones. And most of them are down here at the bottom. Let's click into this graph. It didn't work. It's because I need to be in the checkout service. And I need the heat map of duration. Okay. So is it normal for get discounts to take that long? I don't think so. It just started 2 hours. That matches the pattern. If I look at that trace again, I can ask, like, is it normal for it to have this many selects inside it? Or are we doing some sort of n+1 query thing going on here? I can go look at one that's lower in the heat map, so slower duration. I can find get discounts. There it is. And no, that one just has one child. I can be like, okay, I could be like a lot more things. I could go farther in this.
Let's take a step backwards here, right? Like, let's take a step back and talk about what this would have looked like in a different, without observability, right? Without observability, you might have had a dashboard by service. You might have had a dashboard by, even user ID, but you definitely wouldn't have, thought to have a dashboard by discount code, right? Like you might have, or maybe you did, right? Like, but that would have been a matter of getting lucky or not. Whereas in this case, Jess was able to figure out what happened without any kind of advanced knowledge of what she was going to be querying about, because she was able to kind of iteratively explore and figure it out.
Right. Also, I mean, I didn't want to cheat initially, but really, this alert came in on Slack. Customers can check out will violate our service level objective. And when I click on that, it takes me to how much of this can we automate? Oh man, I've already violated my service level objective. This is not going well. But that alert actually came in an hour and a half ago. And it immediately shows me, here are the bad ones. Here are the good ones. And here's your bubble up right here. The ones that violate SLO versus the ones that don't. And there's yoink right at the front. So if you have a service level objective that's noticing that checkout is slow, this is even faster.
So I want to take a little bit of a step back too, right? And I think this demo is great to sort of show it in practice, right? And this is the way that Honeycomb does it. But like stepping back, right, in terms of observability, which, the book is all about how to achieve observability, right? In early chapters, we just talked about what the data types are and what some of the practices are, right? But fundamentally, what we're showing is that core analysis loop, right? Start with, the overall thing that prompted your investigation, right? What did this alert tell you in this case, right? That SLO violation. And then verify what you know is true, right? Like the way that Jess started her demo, right? There is a data visualization that helps you identify changes in behavior, right? As like a curve, or in this case, right, it was like differences in a heat map, right? You can very clearly see where outliers are. So in those outliers then, right, go through the loop, right, which is search for dimensions that might indicate a change in performance, right? And so you examine some rows, right? Are there any outliers in that data, right? Like different attributes that Jess was looking at to perhaps get a clue, right? Slice across different dimensions, right? Try an experimental grouping by useful fields like status code or service name, or in this case, discount code, right? And then filter, right, for particular dimensions with values that better, expose like why are those outliers occurring, right? And if you know enough about what is wrong now, cool, you're done. If you don't, right, sort of like Jess's analysis in the beginning, right, you go through the loop again and you put in new attributes and new values. The way that Honeycomb does it, we just automate that loop for you, right? That's what Bubble Up is doing. It just systematically goes through your data and tries all of those different combinations and groupings, right, to highlight and bring to the forefront which are the ones that you're looking for. If you were to build this on your own and do it with a different observability tool, cool. That loop though, right, that way of drilling down and figuring out what are the attributes responsible for making these requests outliers and take much longer than other requests in your system, right? That analysis has to be either done manually or automated somehow, right? Honeycomb solution to that is Bubble Up.
Well, gosh, George, what technical characteristics would your system need to have to be able to support this?
Well, I guess we could go into the next chapter, right? Right, the core analysis loop methodology for fault localization, more or less, right? And just discovering like where are issues occurring? How do we get there, right? And so in order to enable that sort of investigation and analysis, right, all of those wide events that you sent into your data store have to be retrieved out of that data store. And so chapter 16, I think, is great because it starts with what are the functional requirements that you need from a data store in this case, right, to analyze your events in the way that we just showed, right? To like get that iterative investigation cycle going, what do we need? And so I think in the next slide, we start getting into what some of these are. And I actually don't remember what they are, so please, yeah, boop it.
I got this. I got this. It's all good. Yeah, we originally were like, I'm not sure if Liz is coming. Okay, George, you better cover in a hurry. I got this. So yeah, basically, as Jess was showing, imagine if Jess's demo, instead of taking less than half a second, maybe 2 seconds for a slow query, imagine if Jess had to wait 2 or 3 minutes between running each query. That would really suck, right? Like that would make you much more likely to say, I'm going to get up, I'm going to get a drink of water, I'm going to go and brew a cup of coffee, right? And that really inhibits...
It would make me think twice before running another query. Do I even want to try?
So observability has to be fast. If it's not fast, then, your observability data store has to be fast in order for you as a human being to achieve the socio-technical confidence that you're going to be able to solve problems. So iteration is super, super key because otherwise you can't formulate and test hypotheses really quickly. Next item. Okay. Any field must be queryable. Why? You cannot bake the cake, right? That if you have pre-aggregated your data, then it's like saying, hey, I've baked this angel food cake, but actually what I wanted was a chocolate cake. Oops, right? Versus if you have the raw ingredients on hand and you're just assembling them on the fly, that lets you answer, follow the trail of breadcrumbs, go wherever the data takes you, rather than looking only at the pre-baked data that you have. Next. Oop. So that gets to the next one, right? Like if you have to be able to query by any dimension, and if you pre-aggregate, then that prevents you from querying by multiple dimensions at a time, or by filtering for a specific dimension and then saying now group by this other dimension, right? That often we find patterns that are inside of the noise, and that you have to be able to sift through rather than looking at the entire noise at the same time. So for instance, imagine if if one user were causing the problem, Jess might have had to graph the discount code and then graph the user ID and see, squint, yeah, they look about the same, but are they actually the same, right? If you've pre-aggregated, you don't know for sure. Oop. And even if the data is aggregated, you have to be able to access an aggregated data. You have to be able to formulate, go back and be able to formulate new hypotheses. So just to reinforce that this is not just a honeycomb thing, I would argue that when I worked at Google, we had actually decent quality observability. And yes, at Google scale, it turns out metrics are pre-aggregated metrics can be a super valuable tool. But the thing that we were doing there was we were using something called exemplars, where you could literally click into any interesting pre-aggregated metric and see all the raw fields associated with one of those, with one example of that. So kind of that enabled us to, that was a hack, a workaround for that scale. But most of you on this call are probably not working at Google. So you don't have to deal with that problem. Boop.
One's a double boot, actually. One more. There we go.
So you cannot privilege retrieval and performance for any particular dimension. Either you have to have an index on everything, or in our case, the way that we think about it is everything is just stored in, not indexed, but in a efficient format, so that you can get through it relatively quickly, which then gets to the any query must return results in seconds. I'm going to put an asterisk on that. Today, our experience is that, yes, if your system depends upon traces, trace ID is probably a good dimension to have a special index on. But like anything, the main thing is everything must be fast. Boop. First ingested data must be available for query within seconds. Why? Because your data changes second to second. It's probably not going to make a difference whether it's 10 millisecond delay or 20 millisecond delay. Like, that's the amount of time that's taking you as a human being to, your brain to go to your mouse to click the refresh button. But at the end of the day, if your systems are changing, you want to see, has a problem gone away, right? Like, you need that signal rather than waiting a minute or 5 minutes for your metrics to refresh to say, yes, you've solved the problem, or no, it's getting worse.
Oops.
And then finally, the data store must be durable and reliable. So observability providers, we're here for you in your worst moments, right? Like when you are having an outage, you don't want to also be fighting your observability store when everything else is down. And in our opinion, we're going to get to this in build versus buy, but this is a huge argument against build. Because correlated failures are really, really bad. Let's suppose that you muck up your virtual private cloud configuration, you're not collecting any data, and you don't have the and your services are down, but you don't have the data to debug your services. So yeah, service level objectives, we think that it's important to have your observability provider in a non-correlated failure domain, aside from, yes, the internet depends on US East 1, but also that it should be about, at least 3.5, 4 nines available to correspond to being there when you have a problem. Oop.
And in fairness, you could build that way, but it is, right, again, like a requirement of how you build, right? If you're thinking about that level of durability and.
Well, this is like, we use Honeycomb to debug Honeycomb, but we don't use the same instance of Honeycomb. It's a completely separate, I don't know, is it in a separate account? It's
in a separate VPC. It's got its own auto scaling groups. It's got it is an entirely separate copy of Honeycomb. And we even, we don't do anything special with peering. It's literally like, transmitting data to another copy of api.honeycomb.io.
So I particularly love this chapter because in order to, really introduce that iterative investigation, right, and the explorability of your data, right, this is what you need to ensure is true when you build a data store. Right. And so chapter 16 was particularly fun to work on because the rest of the chapter, if you haven't read the book, is a case study on Honeycomb's retriever and how we solved some of these issues. And I love it because it's kind of Liz likes to call it the show your work chapter, right? And it's very much, showing it's achievable, right? You can do this. And here's an example of how Honeycomb did it, right? And like how we overcome some of these challenges. And it's a pretty deep dive into that. So absolutely recommend picking up the book and diving into that. If you want to know, one, just like what the inner workings are of a data store that operates in these ways, right? And I don't know. I think it's
I had in my mind, the same kind of show your work as when Google wrote the Dapper paper, right? Basically taking inspiration from all of these like academic papers to say, this is how you actually build it, and also to give you a blueprint if you do choose to build your own.
For sure. And so I think that sort of leads into a little bit of building or buying, right? Should you buy an observability solution or should you build your own? And there are arguments each way. And when writing this chapter, we had to take a little bit of a step back, right? Because the authors, me, Charity, Liz, right? We all work for an observability provider, right? So of course, our answer is going to be, you should just buy it because, we're vendors. But if you build, right, how and when should you make that decision? And I think really when we look at this chapter, it's sort of breaking down, I think, methodically what your considerations should be, right? So we start with basically looking at return on investment, right? And so what are the risks, right? What are the real risks when you build versus what are the risks when you buy, right? And the risks when you build are a few, right? One, it seems like you're building for free, right? Usually when you're using open source components to put together a stack, right? But you are spending developer time, right? Which is scarce. And in some cases, what it means is, folks will put together an observability team or a set of engineers that now own this internal tool or stack or the thing that you decided to build. And a few things happen. Either you need a lot of folks on that team to just iterate and create new features and sort of design for your users and get feedback, right? You have to look at the cost of what that free software is really costing you, right? The salaries of that team, the opportunity cost of not being able to move quickly, but needing to like build that thing and maintain it over time, right? So we start with that. And I think what I'll say about the build use case, there are some times when those costs, which add up, right? If you think of, a typical engineer salary, right? So I don't know, in the Bay Area these days, like $200K per engineer, the time it takes to recruit and build that team, you can very easily, and that's not even looking at infrastructure costs and storage costs, right? You can very easily start to get into, $1 million budgets to build and maintain a system. That
on the other hand, it depends
in
upon your
cases.
company, right? Like if headcount is easier to come by than money to pay to vendors, then
Yeah.
you might have an easier time of it.
Yeah.
I have to say though, with companies doing layoffs these days, headcount is actually becoming a tighter commodity. The other interesting thing I'm going to point out here is that it's not a binary spectrum. We were actually just talking about this in the chat comments, right? Like if you are building, you are probably not building everything completely from scratch. Most of the time when we talk to people who are building, they're leveraging existing open source components. And leveraging existing open source components is great, right? Like we do that too. We use Kafka for part of this. We use, things like S3, we use OpenTelemetry, right? Like these are things that can be helpful. And if your organization has very specific contextual requirements that make it so that none of the existing things quite work and you need to customize and you need to tailor, great, go for it.
Absolutely. I was at Monotorama, 2 weeks ago? And there was a really great use case from a company where the team was spending 8 figures on their monitoring and observability tools.
That's
and built
tens of millions.
That's tens of millions, right? And built their own and they were able to reduce that spend into the low seven figures, right? So into the low millions. And when you're looking at those, like that kind of scale and that kind of savings, absolutely, it 1000% makes sense. Go ahead and make the investment, right? And so to Liz's point, right, it's not that extreme. It is a spectrum of concerns. You know what I probably should have done as a vendor, I probably should have started with like the pro build arguments, right, rather than the against build. So let me talk about those for a minute, right? When you decide to buy a solution, there are risks there too, right? When comparing costs, right, it's very easy to see like what a vendor tool is costing you, right? Like what are they billing you, right? That's what you're paying. But there's some hidden risks and some hidden costs there as well, which namely means that a vendor may not find the same things that your team finds important, equally important to them, right? And so one, you need to make sure that the product that you are buying is relatively well suited to your needs, or that you can extend that product and build to your use case, right? Your vendor may not necessarily make optimizations that work particularly well for your team. And when you have your own stack and you build it yourself, absolutely, you can customize to your heart's delight, right? So when looking at commercial solutions, one of the big things to look at is how well can you actually adapt this to your particular team, right? And your particular needs. And so the chapter, I think, does a really good job of breaking this down and also looks at just extensibility. And I think tries to posit that it's not an entirely like build versus buy spectrum. There's kind of a third option there, right? Which is you can buy a solution and build on top of it, right? And build customizations for your team if you have a reasonably extensible solution that you're looking at.
Yeah, and a lot of observability teams wind up implementing wrappers around OpenTelemetry that they provide to all the other teams in the organization to make observability both more fertile because there's commonalities across the org and easier internally. And they build that on top of, well, it's not a lock-in with OpenTelemetry, but on top of, for instance, buying the data store and the query engine.
Yeah, one of the most pernicious things that we see with people who attempt to build certainly has been everyone hates running their own elk stack, right? Like elk stacks just swallow engineers. Like it's free, as my friend Heidi Waterhouse says, free as in puppies, not free as in beer. Overall, the place for kind of in-house observability teams when you are working with a vendor is kind of around this question that came up earlier around, how do you standardize trace fields? How do you standardize the way that we do things at, around observability at the company? How do we train and empower people to, adhere to the best practices at the company?
Yeah, because the value of distributed traces is the in-between. It's how it shows the connections between the services. And for that, you need some standard way of sending those traces and connecting them.
There's a comment in the chat that I want to highlight, right? And so I'm going to read the comment verbose. The comment is, when I worked in identity, when trying to interoperate, what would take minutes to hours to deploy with a standards-based solution would sometimes take weeks to months when doing it in-house, right? And so I think the point that this comment is trying to make is that there are risks when building, right? And I think one of the common things that I see in terms of building a solution is you think you will just build your observability stack and like set it up and like cool, you can just move on, like the solution is done. But
nope, it's a puppy.
Exactly, right? You're going to have to care for it. You're going to have to maintain it.
And the positive is you own those changes. So if what your organization needs is different from what a vendor would prioritize, you control that. The negative is you also pay for that. It becomes your job to keep up with industry standards, with the state of the art. Every change, every improvement in observability worldwide is an improvement that you have to make to your product.
At the end
So
of the day, right, like if
that's it.
you are building a platform, you have to ask the question, what is unique to your situation and your organization versus what is something that is kind of more generalizable? And for the things that are unique to your organization, you need to have product management, right? I think this is a thing that we've all learned the hard way over the past 5 or 10 years, that just because it's an internal service does not mean that it, that is not a product that you're building. And as people are saying in the chat, like, that means that if it's a product you're building, it needs to have dev, test, and you have to, yes, you have to test and deploy it in prod, but who watches the watchers, right? Like all kinds of fun and interesting issues emerge when you start treating your platform as a product.
Yeah. It needs to have marketing. Yes, that marketing is internal, but you need to get the information out there and get people using it and using it well.
Yeah, because like it or not, even if you build, congratulations, you are now competing with external people who are doing skunkworks IT who are buying from the outside. This is actually a fun thing, by the way. If your organization has chosen to build anyways, you should still talk to us. Like we know ways of helping you get a skunkworks IT project approved. It turns out that there isn't going to be no one true way at an organization. There's always going to be kind of a plethora of different vendors, one of the vendors being internal.
I think, you know what, one of the underrated things in that, Liz, is user experience, right? And usability of the interface and the tool that you decide to build and put together, right? And so one of the things that is interesting when, really building for the needs of your team internally, right? If you have a sufficiently large organization, the team that developed your observability tool may not be the same as the teams that are using that observability tool, right? Or you may develop for a couple of like local teams like next to you, but when you start looking at organization wide, are other teams going to work in the same way? Are they going to understand the interface? Are they going to be able to learn and use the thing that you've built in a very opinionated way, right? And so one of the things about choosing a commercial solution, right, is that there's design, right? There's a lot of thought put into usability in a variety of environments, right? And trying to do things in intuitive ways that make sense to a variety of users, right? And to Jess's point, right? Some of that marketing, some of that education, where is that coming from? How are you doing that, right? And so your vendors will usually have a solution for that. If you're thinking about building, then you need to account for that, right? And you need to account for those costs, and you need to build that into your plan and factor that in when looking at ROI, right? What is this, free solution that you built really actually costing you in the long term? There are cases, again, where it's absolutely worth it, but I think what the chapter is trying to drive is how do you look at all of those considerations, right? And so I think it's a really good roadmap to just laying out what are the many things that you have to think about so that you can actually make a really informed decision on return on investment, right? The only way you can understand that is understand what are you actually investing. So I think the chapter does a pretty good job of walking through it.
Yeah, great. It's time for Q&A, I think. What do people want to know? Throw your questions in the chat, I guess.
Boop, I think, for the Q&A slide.
For the, well, this is the survey slide. You can tell because it's flipping around. Right, and the link is in the chat to the survey. If you complete the survey and you put in the secret word of event 4, then you will get a t-shirt. Yeah. And
there was a question earlier in the chat that I said we would get to when we talked about data storage, and we kind of didn't. So the question is if we get into schema of structured events in practice in the book, and kind of sort of was my response. We sort of talk about it in the CI/CD chapter that was contributed by Frank Chen when we talk about naming conventions. But this question specifically wants to know whether or not you need or want a consistent structure of your events, right? If each of your services is emitting traces in a slightly different format, does it make it harder to search that data within your observability tool? What are some of our recommendations there?
Frank is here. Do we want to like ask?
Oh, is Frank here?
Yeah.
Oh, look at that. All right.
Frank, if you want to speak up.
There's a little bit of a section. I don't know if Frank can speak up in this webinar, or if we can promote him to a speaker, if he is interested in answering the question.
Test 1, 2.
There we go. There's a little bit of a session or section about naming conventions. So Frank, what's your take?
Hey, like this is actually a pretty funny segue. Like I was thinking about this a month ago. So I'm just like getting back to work. I just had my honeymoon. I got married. It was awesome. The week before I left, I actually instrumented a few wrappers around OTel for Slack's Kubernetes platform. So Slack internally, we have a few different sidecars and ways to run Kubernetes at scale, namely around the network layer and how we, not super important and relevant, but making a common library. So whatever team that is working on their various Kubernetes services gets a lot of instrumentation for free. And then when they want to, they can simply import a single Go library with a set of recommended dimensions. They're able to use that and kind of like borrow some of the same conventions and just bootstrap whatever it is that they're working on a lot faster. Having said that, the libraries and the wrappers that I've helped sprinkle around a few different places so far, I'm still trying to socialize. And one, like, there's like always this tension, right? Do you want to be like overly prescriptive with your dimensions or not? I always lean towards not. Like, I think keeping them as strings lets developers in whatever part of the code base be able to contribute and use this arbitrarily, this like super cool arbitrarily wide data store and query engine that is Honeycomb without, like forcing you to do potentially 2 or 3 different commits across separate code repositories to be able to use like this kind of like simple wrapper to send stuff to OTel. And I think
this goes to the backend flexibility too, right? Like in Honeycomb, if you mess up your column names, that's what the coalesce derived column operator is for. Whereas if your data store is much more of a, you have created a metric, congratulations, right? Like, you have to standardize that because otherwise you're creating too many metrics that can't be aggregated together if they have different names, if they have different data types. So I think this is a question that is contextual depending upon the flexibility of your backend and how costly it is to make a mistake. I put air quotes around that because it's not actually a mistake and then converge later.
One other bonus to just adding a new string whenever you need, these are double quotes, you putting double quotes around a string whenever you need a new column, is that I can search for that in the code. So if I see app.discount code, well, where did that get populated? What exactly am I talking about? I can search the code for that and find it. I don't need to dig through 3 levels of abstraction. It's really nice. Frank, did you have anything more on that?
I was going to another question, and this was answered in the chat, but I don't know if you want to speak to this one. It was a question around your demo, Jess. And
the SLO one?
Yeah, the SLO one. So basically the SLO alert in Slack that you clicked, right, took you to a page that automatically showed what was there. How does that work?
Right. So there was the bubble up where I like drew the box around things, and then it was able to contrast the things in the box to the things not in the box. With the SLO, when you make an SLO, you define a function that says, is an event good or bad? So there's like this categorization function represented in this derived column. In this case, the customers can check out SLO has an SLI, which is service level indicator column that says, okay, if this is a /cart/checkout span, then we care about it. And if we care about it, we look at its duration and compare that to 1200 milliseconds, so 1.2 seconds. And we look at its status code, which we want to be 200. And if it meets these conditions, it's good. And if it doesn't, it's bad.
While
Okay.
Jess is coughing, I think this is the really fascinating thing about SLIs is that SLIs let you be prescriptive about what it is that is important to you, right? To say, this is what is important to our customers. This is where our threshold is. Our systems are not guessing for you and saying, hey, we think there's a random anomaly and it's not in something important. You tell us what's important, or actually one of the things we're thinking about is helping you decide on what those rules are to suggest that. But the important thing is you draw a line in the sand somewhere, and then our systems help you adhere to that line. So, previously Jess had to draw the box explicitly with bubble up because, let's suppose she didn't have an SLI configured. But when you do have an SLI configured on customer experience, we want to help you drill down to figure out, why are we not meeting that, and to meet that customer experience target as quickly as possible. Back to you, Jess.
Right.
Gesundheit.
Thanks. Attack of some piece of dust. Right. So that formula lets the SLO know which events are bad. In this case, they're slower, so you can see them in the heat map, and which events are good. And it can compare those and do the statistical analysis on the columns and just give you a heads up for debugging. I love this because, like, when the pager goes off, I know, one, how urgent is it? Is this we're going to run out in 4 hours, or we're going to run out in 24 hours? And I just get a head start on what might be wrong. Any other questions on this? Oh, Liz, I had a question for you.
Yes.
When we were talking about the qualities a data store needs, one of the, I guess I should share the slides. I need that anyway. One of the qualifications was, if data is aggregated, you must be able to access unaggregated data. Is that like, I mean, we look at aggregations in Honeycomb all the time in the form of graphs, but then we click somewhere and we get to unaggregated data as the form of a trace.
That's the form of a trace, or in the raw data view. That's correct.
Yeah, so the trace becomes an exemplar. We don't have exemplars the way you talked about them as Google, because
we can afford to keep everything. So, it's not just, this, well, yes and no, right? Like, it turns out that a sampled trace, because we recommend that our customers sample at large scale, a sampled trace is an exemplar. We're just kind of
that there's
not treating it as a separate data type from the metric, right? We're deriving the metric from the sampled exemplars.
I think it's really important to be able to get from those aggregations, those metrics, to the trace, and then also back when you back from the trace to the aggregation to say, is this normal?
Yeah, it's the hypothesis formation piece. It helps you understand what might be separating the good from bad experiences, or the, fast from slow, or the, user seeing weird errors, right? And then you can then go and run another query to figure out if your hunch was right. 100%.
Cool.
But I think while we are on this slide, like, one thing I'm going to emphasize, because like we actually didn't talk specifically about Honeycomb's implementation, because again, like, we're trying to keep this relatively, like, high level, right? Like, is basically, we are pretty confident that even if you build, you're probably going to want a column store, right? I think this is where we're trying to drive at, is you're probably going to want some kind of high performance column store. There are a couple of companies in the field and open source projects in the field that are building off of things like Yandex's ClickHouse, right? And ClickHouse actually satisfies a number of these properties, but it's not purpose-built for observability. You would have to build a lot of the kind of wrappers and scaffolding around it. But it does have this same idea of, you don't pre-aggregate, you query everything on the fly, you store each column, each dimension separately, so that you can only read the data that you have to, right? There are all kinds of interesting tips and tricks on how to do this. And again, you can use an engine that someone has already built, where they've kind of mostly bashed the heck out of it, although you may encounter observability specific workload works. You can use, Honeycomb's engine, which is great, or you can fall down a lot on all of these, like, issues, right? Like, all of these kind of caveats if you are, like, actually building completely from scratch.
Does sound kind of fun.
I mean, if that sounds fun, you guess what? You're in the right place, Jess. You're working at Honeycomb, right? Like, if you like these kinds of challenges, come work here. But if Yeah.
Yeah, that's the other option. I think of it as our limitation as developers and as an organization is how much we can know. And if this is the kind of stuff you really want to build knowledge about in your organization, then there might be value in it. And if what you really want to build knowledge about is whatever the heck your business actually does that isn't this, then maybe not. Then maybe buy. Go presentation. Survey ends tomorrow. Upcoming events. Great. So this one's today. This one is not up. No. What's today? It is the 13th, isn't it? Okay. Yes. So tomorrow we have an intro to Ollie workshop. And then there's an advanced instrumentation workshop next week. Both of these are free. And what's the next in the Author's Cut series? George, do you know?
I don't know, but I know that I think Bethany shared a link in the chat, and
Right.
there is
that's
a
the
landing
advanced
page that shows you what
instrumentation.
all of the events in the series are. So check that out. And I think these are happening every 2 weeks. So between now and I think sometime in September, we're covering off on various portions of the book. So check out that link in the chat, and you can join us for the next one in a couple of weeks.
Yep, 2 weeks, July 26th, same time, same bat time, same bat channel.
Ooh, the next one is observability driven development, or I like to say observability during development. That one should be really fun. So hope to see you all there. I'll look for the recording and further information in your email. And fill out the survey, get a t-shirt. They're really soft.
Thank you for joining us.
Thanks, everybody.
Next time.